Okay, good morning. You know that the LM339 is a quad comparator, and each of these constituent comparators are of open collector, are having one open collector NPN transistor at the final output stage. Now, for that means the output is being taken from the collector terminal of one open collector NPN transistor. That means that collector terminal must be available at the output, and to achieve a proper transistor action or proper action of this common emitter amplifier configuration, we need to connect one resistance and one positive DC supply with the collector terminal, that means with the output terminal. Now, what about the emitter terminal? The emitter terminal must be connected to the, from the concepts of your common emitter amplifier configuration. The emitter is normally connected to the ground terminal, ground potential. So that emitter terminal also is taken out, and that will be connected to either one negative potential or one ground potential. Now, as there are four such comparators, we'll have four different outputs coming from the individual final stage open collector NPN transistor collector terminals. Now, all those open collector NPN transistors will be having one emitter terminal each. So altogether there will be four such emitter terminals coming out of the four comparators. Now, what in the LM339 is done is, these four emitter terminals are tied together. That means they are shorted together, and that common point is taken at the is taken outside the IC, and that is connected to pin number 12. So in the pin number 12, if you connect one negative potential or one ground potential, that will go to the emitter terminal of all the four comparators. Is that clear?
Yes, sir.
Yes, sir.
স্যার একটা ডাউট আছে, ওই চারখানা যে কম্পারেটরস আছে প্রত্যেকটার জন্য তো মানে অ্যাট দি আউটপুট অফ দ্য কালেক্টর টার্মিনাল আমাদের একটা করে পজিটিভ ডিসি সাপ্লাই লাগছে। এবার সেটা কি ইকুয়াল হয় প্রত্যেকটার জন্য নাকি?
না না, আমি এক্সাম্পল দিয়েছিলাম, একটা প্লাস 5 ভোল্ট হতে পারে।
স্যার LM339 এর জন্য স্পেসিফিক্যালি বলছি।
হ্যাঁ, আমি 339 নিয়ে বলছি।
ও আচ্ছা,
একটা প্লাস 5, একটা প্লাস 10, একটা প্লাস 2, এইবার।
ওকে স্যার, মানে ওরকম কোনো স্পেসিফিকেশন নেই?
না, কোনো স্পেসিফিকেশন নেই, অনলি একটাই আমরা কন্ট্রোল রাখার চেষ্টা করি, দিস ভোল্টেজ ডিসি ভোল্টেজ শুড বি less than or equal to this DC voltage. That's all.
Yes.
Any other query? Fine. So I'll proceed. Now, in the last class, I gave one idea that with the negative feedback, normally we can assume virtual short between the two input terminals of the operation amplifier. Now, please, any one of you tell me what are the conditions that needs to be satisfied to achieve virtual short.
So there must be negative feedback in the circuit. Circuit should operate in the linear region, and open loop gain should be very large.
Yeah, these three. Out of these three, the open loop gain should be very large, and the op-amp should be operating in the linear region. These two are the sufficiency condition, and the necessary condition is the op-amp must be operating in the negative feedback. Negative feedback does not guarantee that the op-amp will be operating in the the negative feedback and at the same time the linear operation. These two does not guarantee that the op-amp will operate in the will be having virtual short, because
স্যার AOL হাই ভ্যালু অফ AOL ওটাও তো গ্যারান্টি করে না।
Oh, I'll come to that. Now there is negative feedback. Is it not? There is negative feedback. Now, in case my AOL is 100, what will be the output?
10.
No. I don't know.
We have to apply that formula, sir.
Yeah, you have to apply that formula. Probably that was R2 by
R2 by R1 plus
by
R2 by 1 by AOL plus R1 by R1.
1 by AOL plus
R1 by R1 plus R2.
এবার এখানে সাবস্টিটিউট করি আমরা minus R2 is 10, so 10 by 11 by 1 by 100 plus R1 is 1 by 11. একটু কেউ ক্যালকুলেট করবে প্লিজ?
Yes, sir.
Sir, minus 9.009.
Is it saturating? Is the output going beyond the linear output region?
No.
No. So that means the op-amp is operating in the linear region. Okay, op-amp is operating in the linear region. But as the AOL is not infinitely large, op-amp is operating in the linear region, there is negative feedback. But as the AOL is not infinitely large, I am unable to assume virtual short. Because as the output is this much, so what will be your VD? VD will be nothing but V0 by AOL. As the op-amp is operating in linear region, that means my output has got to be AOL into VD. As the output has not saturated, my output is given by AOL into VD. Is it clear?
Yes.
Only when output saturates, there you cannot assume this. But in case the output is beyond, is within the plus minus Vset and minus Vset limit, in that case, definitely op-amp is operating the linear region. So this formula has got to be valid there. So here also I have found that output has not saturated. Output is well within that limit. So what will be my
sir বলছি আউটপুট এটা মানে আউটপুট এটা ইনটু ভিআই হবে না?
Why VI? AOL into VDO.
স্যার ওটা বলছি না, আমরা যেটা ক্যালকুলেট করলাম -9.009 ওটা তো V0 by VI না?
Oh, good. I missed that point. Okay, I assume that this is 1 volt. Thank you. I forgot that. I assume VI is 1 volt. Okay. In case VI is 2 volt, definitely it is minus 18.018. So that means the expected value is beyond that plus minus Vset limit. So output has got to be, in that case, minus 10 volt. Saturated. So there definitely I cannot assume this. So definitely the output virtual short cannot be approximated there. But in case my VI is 1 volt, op-amp, the closed loop in the closed loop configuration is operating the linear region.
Yes.
So there, I definitely can apply this formula.
Yes, sir.
So there also I find that my VD is equal to minus 9.009 by 100. So that will be how much? Minus 0.09 something. Okay. So definitely that is of the order of 90 millivolt minus. So that cannot be assumed to be 0. So even if there is negative feedback, even if the op-amp is operating the linear region, the circuit is operating the linear region, here as the open loop gain is not infinitely large, there is no virtual short. So for the virtual short to be present, all these three conditions must be valid. Negative feedback, linear operation, and at the same time, infinite open loop gain. Okay, may not be infinite, but that has got to be very, very large. That's all.
So
Okay.
very large ki 10 to the power of 5 এর order হবে?
No. We may assume 1,000 or 5,000 to also quite large.
Okay, sir.
But now onwards in my class, unless otherwise mentioned, we'll assume that all these three conditions are valid. That means if I have implemented one operation amplifier circuit having negative feedback, we'll assume that it is operating in the linear region and the open loop gain is also quite large. Henceforth, I'll assume that. If something else is there, I'll specifically mention. If nothing else is mentioned, we'll assume as soon as you find that there is negative feedback, you will assume that linear operation of the circuit and at the same time infinite or very large open loop gain. Okay.
Sir,
Sir,
necessary and sufficient condition এর মধ্যে একটু ডিস্টিংশনটা বলতে পারবেন?
ডিস্টিংশন আমি করতে গিয়ে দেখলাম যে সবগুলোই নেসেসারি হয়ে গেল।
ইয়েস স্যার, মানে আমরা তো ডিটারমাইন করতে পারছি না, তাহলে সবকটাই
পারলাম না।
ইয়েস
আমি সেটাই করার চেষ্টা করেছিলাম, কিন্তু আমি করতে পারিনি।
ওকে স্যার, মানে তিনটে কন্ডিশন ইকুয়ালি ইম্পর্টেন্ট।
তিনটে কন্ডিশন ইকুয়ালি ইম্পর্টেন্ট।
ওকে স্যার।
But definitely your negative feedback না থাকলে circuit cannot operate the linear region ever.
Yes.
If there is no negative feedback, there is no chance of linear operation.
Yes, sir.
Okay.
Yes, sir.
Have I told you that in the last circuit the gain was ACL was minus R2 by R1, so that's why this was called inverting amplifier. Have I mentioned that? This configuration.
Sir, you have not. The last class you have not talked about inverting.
You mentioned phase inversion.
Oh, okay. I just stopped at that point probably. And in most of the books or in most of the notes, you will find that this is called RF and this is called RI. So this will be minus of RF by RI. Why it is RF? This resistance is in the feedback path. So that's why that F subscript come. And here why it is RI? Because it is current to the input side. Okay, so that's why this termed RI and that fellow is termed as RI. Whatever it is, I find that there is 180 phase inversion due to this minus sign between the output and the input. So that's why this configuration is called one inverting amplifier. This is called the inverting amplifier configuration. Let me go for the other version. Is there negative feedback here? Is there any negative feedback introduced here in this circuit?
No, sir.
No, sir.
Yes, sir. But I have got two answers who are saying no. Why no? Pandita?
So if we apply KVL, then probably we'll find that it's not a negative feedback.
No. Feedback means what? A part of the output is being fed back to the input side.
Yes,
That is
sir.
the feedback, isn't it?
Yes, sir.
Now, what is the output here?
So V0.
V0. Let this node be termed as VA. This V0 is fed back to which node?
VA.
Yeah.
VA. So there is a feedback.
Yes,
Yes,
sir.
sir.
And the feedback is going to which terminal? Inverting terminal or non-inverting terminal?
So
Inverting terminal.
Inverting terminal. Now, between that inverting terminal and the output terminal, is there any phase shift of 180 degree?
No, sir.
No, sir.
There is only one simple resistance. So that does not introduce any phase shift at all.
Yes, sir.
Okay. So that means
আরেকবার এক্সপ্লেন করবেন স্যার এটা
the output, a part of the output is definitely being fed back to the VA node. That VA node is nothing but my inverting input terminal node.
ইয়েস স্যার
That means a part of the output is being fed back to the input side, but not in the non-inverting terminal. Now here it is in the inverting input terminal.
ইয়েস
Now we have mentioned earlier in the last class that whenever the output is being fed back to the inverting input terminal, in most of the cases that will lead to negative feedback. Why most of the cases? Now, in case between the output and that feedback point, there is no phase shift, or there is no 180 degree phase shift, to be more specific, that will definitely lead to one negative feedback. But
Yes.
if in case there is 180 degree phase shift between the output and the input node where it is being fed back, in that case, in case the output is being fed back to the inverting input terminal, that will be one positive feedback.
Yes, sir. So that
That
is
we-
irrespective of to which terminal we are applying the input voltage.
Definitely, with respect, it does not matter in which terminal you apply the input potential, because the feedback does not depend on the input terminal. It
Okay.
depends only on the output terminal and the node where it is actually fed back.
Okay, sir.
Okay.
স্যার মানে আরএফ যদি আরএফ এর
আর
মানে
যদি 180 ফেজ শিফট দিত তাহলে কিন্তু এটা পজিটিভ ফিডব্যাক হয়ে যেত।
ইরেসপেক্টিভ অফ মাইনার মানে ইনভার্টিং টার্মিনাল কি
No. In case forget about RF. Here I have one network.
Yes, sir.
Here I have one network which is introducing 180 phase shift. Now, as the output is being fed back to the inverting input terminal, and as there is one phase shift of 180 degree, will be having positive feedback effect. But had it been like this, had it been like this,
Yes, sir.
in that case, as the output is being fed back to the non-inverting input terminal, and in between I have 180 phase shift, the resulting effect will be that of negative feedback.
Sir, last line tag repeat করতে পারবেন?
Yeah. As the output is being fed back to the non-inverting terminal,
Yes,
and
sir.
in between we are having 180 phase shift, so the effective feedback feedback nature that will get will have from this configuration will be that of positive feedback. Sorry, negative. Sorry. আমি কি আগেও পজিটিভ ফিডব্যাক বলেছিলাম?
Yes, sir. Negative feedback.
That will be
Yes,
negative
sir.
feedback. That will be negative feedback. Okay.
Yes.
That's it. So you have to be careful which input terminal the output is being fed back, inverting or non-inverting, and whether in between in that feedback path there is 180 phase shift or not. That's all. These two things you only have to look for.
স্যার
Okay.
স্যার
হ্যাঁ বলো।
তো এখানে 180 ডিগ্রি ফেজ শিফট হলো আর এখন নন ইনভার্টিং টার্মিনালে গেল ফিডব্যাকটা তো ওটা এফেক্টিভ
That will be
হলো নেগেটিভ
negative
ফিডব্যাক হলো তো পজিটিভ
That will be negative feedback. That will be negative
হলো
feedback.
তো
হ্যাঁ।
আচ্ছা আর যদি এটাই ফিডব্যাক যেটা যাচ্ছে এই কনফিগারেশনেই কিন্তু যদি মাইনাস টার্মিনালে যেত মানে ইনভার্টিং এ যদি যেত
In that case, that will be positive feedback.
আচ্ছা ঠিক আছে
Okay, thank you.
Sir, আমরা যে বলছি কি like if it goes to the negative, if it goes to the non-inverting input terminal, it will be a negative feedback. That is just a rule of thumb. No, that is not the actual reason for the negative feedback.
No, that I explained in the last class at the very beginning.
Exactly, sir. That is মানে আমরা বলছি কি নেগেটিভে গেলে ইনভার্টিং হবে, এটা মানে নেগেটিভে গেলে নেগেটিভ হবে, মানে ইনভার্টিং এ গেলে নেগেটিভ ফিডব্যাক হবে।
আগের ক্লাসে ওটাই আরেকবার বলি তাহলে। হ্যাঁ
না স্যার আমি বুঝেছি স্যার, আমি বলছি কি যে ইনভার্টিং এ গেলে যে নেগেটিভ হচ্ছে স্যার ওটা জাস্ট রুল অফ থাম না, মানে ওটা
it is not rule of thumb. It is not rule of thumb.
স্যার রুল অফ থাম তো ইনটু 10 করলে কোয়ান্টিটিটা অনেক বেশি হয়।
That is rule of thumb. It is not rule of thumb. This is the property of the op amp, because your output V naught is equal to AOL into VD, and what is your VD? VD is always V non-inverting minus V inverting. VD is always that V2 minus V1, non-inverting minus inverting. That will be always your VD. And from there, the op amp output is AOL into VD. So just because of this, if the fraction of output is being fed back to the inverting input terminal and there is no phase shift between the output and the input. Output and input means output terminal and feedback input terminal. If there is no phase shift or there is no 180 degree phase shift, to be more specific, in that case, that has got to be negative feedback. Otherwise, if there is 180 degree phase shift, that will be one positive feedback. That we explained with the mathematical expressions in the last class. If you want, I can do it once more.
No, sir, it's okay.
আর কোনো ডাউট আছে কারণ?
স্যার ফেজ শিফট যদি 0 বা 180 ছাড়া অন্য কোনো ভ্যালু থাকে তবে?
ইন দ্যাট কেস তোমরা কি কন্ট্রোল পড়েছো না এবার এই সেমিস্টারে পড়ছো?
পড়ছি স্যার এই সেমিস্টার।
আচ্ছা, there you will find that there is something called phase margin, gain margin. Have you heard of these terms?
No, sir.
No,
So
sir.
when finding out the stability criteria, in fact, the control system means what? You need to control the operation of one plant or one process in such a manner that remains stable. The operation remains stable. Okay, so that means je kono system we need to find out the stability. There are two types of stability that we are concerned. One is absolute stability, the other one is the relative stability. Absolute stability জন্য তোমার Routh-Hurwitz criteria, there are several other criteria also. All those details the ma'am should explain. And to find out the relative stability, we go for finding out the phase margin and gain margin. What they mean, ma'am should be able to tell it much better than me, because I learned it in my UG classes only, and in PG also I have learned to some extent. But the thing is, if I have two systems, if I find that the phase margin and gain margin of one system is much higher than the other one, that means we there comment that the first system is more stable than the second one. So the phase margin, gain margin, they're basically concerned about the relative stability. When you compare two systems or three systems, there we find try to find out the phase margin, gain margin, phase margin, gain margin, what do they mean? Basically, up to how much gain I can increase till the system becomes unstable. That's the basically the gain margin. আমার এখন একটা certain gain পেয়েছি, এই gainটাকে আর how much I can still further increase the gain so that the system will become unstable there. So that becomes the gain margin. Similarly, phase margin is there. Phase margin also concerns that phase-টাকে আর কতখানি vary করালে our systemটা unstable হয়ে যাবে. So that concerns about the phase margin. So here in this negative feedback circuit or whatever feedback circuit you are having, in case in the feedback path there is a certain phase shift introduced which is neither exactly 0 nor exactly 180 degree, there we should be concerned about the relative stability there. We should be concerned about the phase margin, by how much how much phase variation we can allow for this circuit to become unstable. So that phase margin will be affected there. If there is no phase shift at all, we'll say that the system is absolutely stable. If there is 180 degree phase shift, we'll say the system is absolutely unstable. You know that the positive feedback circuits are basically unstable circuit, because the output will be either plus Vset or minus Vset. So in case you have one positive feedback network, if there is certain increasing disturbance, the output will increase in an unbounded manner. Ideally, it should try to reach the plus infinite potential. But as it is on physical circuit, it cannot reach the plus infinite potential. It will be clamped to the plus Vset level. Similarly, if there is one decreasing disturbance, the output will go on in an unbounded manner towards the negative side. Ultimately, it should try to reach minus infinite potential, but it will get clamped to minus Vset level. So any positive feedback network is inherently unstable network, whereas any linear network are stable network, but they might be having certain relative stability factor. So তুমি যেটা বলে সৌম্যজিৎ, যে if there is some phase shift which is neither 0 nor 180 degree, then that means the system will not be absolutely stable. There will be certain phase margin there involved there. Okay, but those details you should be able to conceive in much better manner once you come across those points in control systems. আর কিছু? Anything else?
No, sir.
Okay. কোথায় ছিলাম আমি?
Sir, part of VA feedback.
Is there any negative feedback here?
Yes, sir.
Yes, sir.
Fine. Now, as there is negative feedback, we are assuming the other two conditions to be valid. That means the op amp is operating in the linear region and there is almost infinite open loop gain. So that means in the circuit, as soon as we find that there is negative feedback, we will assume virtual short. Why you can assume virtual short? Because we are assuming the other two conditions. Okay. Henceforth, I will be doing this thing only. We will be just looking for whether there is negative feedback or not. And if there is negative feedback, we will assume the other two conditions to be valid also. Okay. I won't repeat henceforth.
Okay, sir.
Yes.
Fine.
Okay, sir.
So as there is negative feedback, there is virtual short. So this terminal should be which potential?
VI.
VI. So I will write that. Now apply KCL at this node, at this inverting input terminal node. So if we apply KCL at that node, what will be getting? VI by RI will be equal to V0 minus VI by RF. Is it not?
Oh, yes, sir.
So from here, V0 by Vi will be equal to nothing but 1 plus RF by RI. Okay. Is it clear?
Yes, sir.
Yes, sir.
Fine. Now, what is the phase relationship between V0 and Vi?
Phase.
They are in phase. They are in phase. So there is no phase inversion between the output and the input. So this is called one non-inverting amplifier. This is called one non-inverting amplifier. Okay. So in the inverting amplifier, what was the gain? Minus RF by RI. Is it not?
Yes, sir.
And in non-inverting amplifier, the gain is 1 plus RF by R. Fine. Let me draw that inverting amplifier also here in the same page. Now, my second point that I want to discuss is what are the input impedances of the two amplifiers, inverting amplifier and non-inverting amplifier. What is the input impedance that you find in the case of inverting amplifier?
Infinity.
For the inverting amplifier?
RI. R input যেটা আছে।
Let me see what the others say.
Sir, আরেকবার question repeat করতে পারবেন?
What is the input impedance for inverting amplifier? This one.
আচ্ছা।
So I have got two answers, RI 0 and somebody probably said infinite. Any other option? I require at least 4 options so that the MCQ is complete.
Sir, RF.
RF, good. So there are 4 options with me. Now let me go for any extra.
RI parallel to RF?
Yeah, very good. RI parallel to RF. Okay. So I have 5 options. Now, what do you mean by input impedance? How do you find out the input impedance? I have one network, two-port network. Oh. How do you find out the input impedance?
Sir, we take a voltage at the input and we short all other.
You have to apply. You have to apply one input voltage here, plus minus. Short the output. I am now forgetting about the output. I will just measure the input current.
Yes.
So your Z in or Zi will be nothing but Vi by I.
Vi by I.
Okay. So let me do the same thing here. Let the Vi be connected here. This was your Ri, this was your Ra. Okay. When you are connecting this Vi, and what will be the input current? Input current will be nothing but this current. Is it not?
Yes, sir.
Now, what is this potential? What is this potential?
Zero.
Yeah, that's zero.
Assuming virtual short.
So virtual short or zero.
Virtual short, so that has got to be zero.
Yes.
So what is the value of II?
Vi by
Ri.
Vi by
I.
So I have got Vi. I know the value of Vi. I have obtained the value of II. So let me find out the Z in.
So II will be flowing outwards now.
Why outward?
So 0 minus
That
Vi
depends
by.
on the Vi value. That depends on the Vi value. If Vi is positive, the current will be going inwards. If Vi is negative, then only it will come out. So I'm not bothered about that actually, because the II will follow certain sign which has got something to do with the Vi sign. That's all. So I have got II, I have got Vi value. So my Z in will be Vi by II. II means Vi by Ri. So that is nothing but Ri. Okay.
Yes, sir.
So here okay. Now what about for the non-inverting amplifier?
So 0.
Exactly.
Vi by I টা হবে ইনফাইনাইট, তাহলে ইনফাইনাইট হওয়ার কথা।
আর কিছু? হ্যাঁ, শুধু শুধু 0 কেন বললে বলো?
স্যার II তো জানি না স্যার।
ফাইন।
স্যার আড়াই হবে।
আড়াই হবে। আর কিছু?
ইনফাইনাইট স্যার।
রাজদীপ, হোয়াই আড়াই বলো?
স্যার সেম রিজন, মানে ভিআই তো ভার্চুয়াল শর্ট দিয়ে হচ্ছে, মানে ভিআই ইকুয়াল টু ভিআই হচ্ছে ভার্চুয়াল শর্ট দিয়ে, তো সেম কারেন্ট ফ্লো করছে আউটওয়ার্ডস।
No, the thing is you are bit confused. Where are you connecting the input potential? Here?
Non-inverting terminal.
Yeah.
Yes, sir.
So which current you would be concerned about?
Non-inverting.
Yes,
This
sir.
current.
Non-inverting terminal.
It should be constant about this current. This should be your II.
Yes, sir.
So now I have infinite impedance here. The op-amp's input impedance is infinitely large. I know that.
Yes.
So through this non-inverting input terminal, it was wrong. So II is almost 0. So if II is 0, in that case, my ZD in which has got to be V in by I in or VI by II, that should be VI by 0 or almost infinite. Okay.
Yes,
Any
sir.
confusion of anybody?
স্যার তাহলে non-inverting amplifier এর যেই মানে Zin is equal to আমরা যেই
infinite. Basically this is input impedance of the op-amp.
Yes, sir, exactly. Input impedance of the op-amp is equal হয়ে যাচ্ছে তাহলে।
Yeah. Now tell me one thing. In terms of amplifier consideration, out of these two, which one is preferred? Non-inverting amplifier or inverting amplifier?
Non-inverting.
Why?
We require infinite input impedance ideally.
Ideally, for any amplifier, we should have infinite impedance and 0 output impedance. Now, this non-inverting amplifier is allowing you to achieve infinite input impedance. Whereas in the case of inverting amplifier, the input impedance is not infinite. In case Ri is of the order of hundreds of ohms or kilos of ohms, so input impedance is also of that value. Okay, so always definitely we should prefer non-inverting amplifier. But the problem there is in the case of non-inverting amplifier, we cannot have any phase inversion. Whereas in the case of inverting amplifier, we can achieve phase inversion. And in the case of non-inverting amplifier, what is the minimum possible gain and what is the maximum possible gain?
Minimum 1.
Let others say.
Yes, sir. Minimum 1.
Minimum 1.
Minimum 1.
Minimum 1. Under which condition you will be getting minimum 1?
Ri greater than
Infinite.
Ri infinite. Anything else?
RF 0.
RF 0. Fine. Now, in the case of inverting amplifier, what is the minimum possible value? Magnitude wise. What is the minimum possible value and what is the maximum possible value?
0.
0 to infinity. 0 to minus infinity.
Yeah. 0 to no. I'm talking about magnitude wise.
Yes,
so
sir.
0 to infinity. Okay. So that means here in the case of inverting amplifier, you can definitely achieve fractional gain. That means attenuation you can get. Is it not? In the case of inverting amplifier, definitely we can achieve fractional gain or attenuation. 0.5 gain, minus 0.5 gain. We can definitely achieve that. Definitely we can achieve. Minus 0.75, we can definitely achieve. But using non-inverting amplifier, we can never achieve any gain less than 1. Okay? You do get my point?
Yes,
in the case of non-inverting amplifier, the minimum possible gain is 1. Whereas in the case of inverting amplifier, I can go up to 0. Now say I need to achieve one closed loop gain of 0.25 plus. I need to achieve this gain. How do you get it? How do you propose to get it?
Inverting amplifier.
Inverting amplifier, tell me what is the configuration?
So there has to be a phase shift in the RF network.
No, if there is phase shift order of how much?
180 degrees.
180 degree.
Sir, we can use.
হয়ে যাবে।
Sir, we can use 2 inverting amplifiers.
Yeah, that you need to do. You need to use 2 inverting amplifiers. VI এখানে তুমি 4K 1K Okay. But by the way, is this yellow color at all visible?
Yes, sir.
Yes, sir.
Okay, fine. So this is the way you can achieve a positive fractional gain. But there you cannot use in non-inverting amplifier. There you have to use multiple number of inverting amplifiers. So how many op-amps you have used?
2.
2.
But in your lab, so due to lockdown 2 years, there are no lab operating. So after going to the lab, you find that no 3 to 4 IC is working. Only one IC 741 is working. But there are multiple resistances. Whatever resistances you want, I can give you. But I have supplied you only one working IC 741. That means how many op-amps you are having now?
1.
Only one. Only one op-amp you are having. So you have only one op-amp, and you have any number of resistances. So any number of resistance you want, I will give you, but you have only one op-amp. How will you realize 1.25 volt signal from 1 volt signal? I have given you only one op-amp and any number of resistances you want. Your task is to realize 0.25 volt signal from 1 volt signal.
Sir, invert করে তারপরে voltage divider.
Invert করে voltage divider.
Voltage divide করে তারপরে invert. 3টে রেজিস্ট্যান্স নেব তাহলে।
No, in Rajdeep, if you use inversion, in that case from 1 volt. No, this is not very costly. But if you go to the charging market, you can find it in 7 rupees or maximum 8 rupees or so. So that is not costly. But the thing is, due to COVID situation, your mother is not allowing you to go to the charging market.
Yes, sir.
Anyway, যেটা বলছিলাম, Rajdeep, if you go for the inverting amplifier, in that case from 1 volt you will be getting one negative voltage, and from that negative voltage, if you go for the voltage divider, you will be ultimately getting the negative voltage only.
Oh, yes sir, yes sir.
And Parvez, you are telling me that first you will just go for the voltage divider. So from 1 volt, if you go for the voltage divider, that will be one positive potential. Now if you go for one inverting amplifier, the output of the inverting amplifier will be once again negative.
Yes sir, same জিনিস হয়ে যাচ্ছে।
Same thing হয়ে যাবে।
Yes sir.
স্যার আমরা একটা নন ইনভার্টিং অ্যাম্পলিফায়ার নেব, আর যেখান থেকে আমরা আউটপুট নিচ্ছি, যেখানে ইনপুট দিয়ে ইনপুটের জায়গাটাতে আউটপুট নিয়ে ভোল্ট গেইনটা 4 করে দেব, তো 1/4 হয়ে যাবে।
Some sort of that. some sort of that. আমি ওটাকে আরো একটুখানি সহজ করে দিচ্ছি, আরেকটা জিনিস ডিসকাস করে নিই তারপরে।
স্যার আড়াই এর জায়গায় তাহলে ভোল্টেজ ডিভাইডার দেবো?
না, আসছি, আমি আসছি।
Yes, sir.
আবার একটু নন ইনভার্টিং অ্যাম্পলিফায়ার, let me go back to the non-inverting amplifier.
স্যার কোয়েশ্চেনটাতে অ্যাম্পলিফায়ার আমাদেরকে ইউজ করতেই হবে, মানে?
হ্যাঁ, করতেই হবে।
তাহলে স্যার বাফারের মতো কিছু ইউজ করা যেতে পারে?
What is buffer? Have I talked about buffer in this class?
No, sir. মানে বাফারের মতো কিছু, যেরকম ডিজিটাল ইলেকট্রনিক্স পড়েছে।
What do you mean by buffer here? Open the how can realize buffer?
জানি না স্যার।
So this was the gain, is it not? Now একটু আগে যেমন ডিসকাস করছিলাম যে under which condition this V0 by Vi gain becomes 1. What are the conditions?
So RF 0 বা RA infinity.
RF is equal to 0. What does it mean? The circuit now looks like
No feedback.
No feedback. It is not no. RF 0 means what? The resistance value is 0. That means
Short circuit.
shortage. That is shortage. Oh, sorry.
Non-inverting.
You should raise the objection. I am very sorry. What is the other possibility?
Ri infinite.
Ri infinite.
Right. What does it mean? Between the inverting terminal and the ground terminal, there is no connectivity. Open. The inverting terminal and the ground terminal are open. There is nothing connected in between. So the circuit now looks like now. I can do both. Is there any harm?
No, sir.
So that circuit now becomes like this. So all these three gives you how much gain? One. So definitely out of these three, which one is preferred?
The last one.
The last one, because no other component is required other than that op-amp.
Yes, sir.
So no resistances are required. Now what is the gain here? 1. So that means the output and the input are always same. But what is the input impedance?
It's infinite.
What is the input impedance here? Infinite. And what is the output impedance? Very small, because the output is being taken from the operation amplifier output. So that output impedance has got to be very small, because by design the op-amp outputs are having very small value. So in this circuit, though I am having only a gain of 1, but it is having the advantage of infinite input impedance and very small output impedance. So this circuit is called a buffer circuit, or one buffer amplifier. Say I have one amplifier, I have designed one amplifier, I have designed another amplifier. its output impedance is not very small. Its input impedance is also not very large. So if I connect these two, what will happen? What problem you might find?
Loading effect.
Loading effect.
There will definitely be loading effect. To avoid loading effect, either the output impedance of this amplifier should be 0, or the input impedance of this amplifier should be infinite, or both. In case both are satisfied, then nothing like it. Otherwise, at least one of those two conditions must be met. But in case nothing is met, both are practical amplifiers, in that case, I'll be facing the problem of loading. There, these buffers become very handy. I'll introduce a buffer here.
So আরেকবার loading effect বোঝাতে পারবেন স্যার?
Loading effect to
না স্যার এইটার রেসপেক্টে সরি buffer রেসপেক্টে।
Say its output impedance is Z0. Its input impedance is Z in. Now, in case Z0 is 0, if my Z in is not very large, will there be no loading effect?
No, sir.
In case Z0 is non-zero, but my Z in is infinite, will there be any loading effect?
No, sir.
In case my Z0 is also 0 and my Z in is also infinite, will there be any loading effect?
Sir, আরেকবার রিপিট করুন স্যার।
Z0 is 0 and Z in is infinite.
So no loading effect.
No loading effect. Under which condition there will be loading effect? When Z0 is non-zero, some finite value, and Z in is also not infinite, is also some certain finite value, and these two are comparable. Only there will be loading effect, isn't it?
Yes, sir.
Now, to avoid that loading effect for these practical amplifiers, we take help of these buffers. What we'll be doing is, in between these two, I'll be connecting one buffer. Now, what is the input impedance of the buffer?
Infinite.
So, is there any loading effect felt at this node?
No, sir.
No, sir.
What is the output impedance of the buffer?
0.
Not 0, but very small. Very small. So, will there be any loading effect felt here?
No, sir.
No, sir.
So, just by introducing the buffer, I have avoided the problem of loading effect. Now, any of you, if you go to the instrumentation field or in the electronics field, if you are given one chart of a very large circuit involving several operation amplifiers, out of those operation amplifiers, invariably 25 to 30% operation amplifiers will find that they are used as only buffers. The circuits, the complex circuits will be having multiple number of stages. The cascaded amplifier stages will be there. So from between one stage to the other stage, invariably we have to take help of one buffer to avoid loading effect. So though the buffers are a pretty simple circuit, but they do have very large application, just to avoid loading effect between the stages. Okay, is this point clear?
Yes.
Or any doubt? Fine. Let me go back to the previous one. Here. Now, what I'll be doing is, Parvez was saying that, probably Parvez was saying that in case you can avoid using the operation amplifier, you should be able to realize 0.25 volt from 1 volt. How? Now, if I take help of this thing, 1K, 3K. 1 volt. So there you'll be having 0.25 volt, isn't it?
Yes.
Now, if you have got to use that operation amplifier, just use that as buffer. Okay. Now, why should you use the buffer at all? What is the output impedance of this seen from this terminal? If I say this is V01 terminal, what is the output impedance? You must have learned the Thevenin's theorem.
Three
There's
parallel
nothing but
one.
three parallel 1 kilo. There's nothing but 3 parallel 1 kilo. So it should be less than 1 kilo.
Yes.
So that is not 0 or near to 0. So if I connect these to certain load, which is non-ideal node, definitely that there will be a certain loading effect. This node voltage will not remain 0.25. With the variation of the load impedance, that voltage will go on vary. But here, will there be any such loading effect?
No, sir.
No, sir. Because
That's
of the
why
buffer.
this buffer is of so much importance here. Any doubt till this point?
No.
স্যার আমরা যদি নন ইনভার্টিং টার্মিনাল এন্ড ইনভার্টিং টার্মিনাল দুটোতেই রেজিস্ট্যান্স দিই, এটাতে কি কোনো প্রবলেম, মানে কোনো
না,
স্পেশাল কেস
কোনো
হবে?
problem হবে না। ধরো দেখাচ্ছি, মানে এই কেসেই, ইন দিস কেস।
স্যার এনি কেস, মানে নো 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 স্যার, মানে আমি একটা আইডিয়াল একটা অপ অ্যাম্প বলছি।
আমার বলো কিরকম হতে পারে সার্কিটটা?
মানে ভিআই মানে পুরোটা যেরকম আছে, বাস একটা প্লাস টার্মিনালে একটা রেজিস্ট্যান্স দিয়ে
এরকম?
ইয়েস স্যার, এটা গ্রাউন্ড।
না, তুমিই বলো এবার, what will be the output? What will be this current? What will be the current through R1? 0. আমরা 0 ধরে নিচ্ছি, আইডিয়াল অপ অ্যাম্প ধরে নিলে that will be 0. So in case the current is 0, what will be this node voltage?
VI.
VI. So the earlier circuit only.
Okay. Yes, sir.
একইভাবে তুমি যদি এখানে কোন রেজিস্ট্যান্স ধরো, same thing, doesn't matter. So far you are assuming infinite impedance of the op amp.
Yes, sir.
If you assume that there is one resistance here, there is no current through R2 nor any current through R1. এদিকেও কোনো কারেন্ট নেই, এদিকেও কোনো কারেন্ট নেই।
Redundant হয়ে গেছে।
Yeah, this R2 and R1 becomes redundant. Okay.
Yes, sir.
But definitely, if you go for the consideration of the input bias currents, they will come into picture. But we assume for ideal op amp, the bias currents are 0. As we have assumed the infinite input impedance of the op amp. Okay?
Yes, sir.
is there any negative feedback?
Yes, sir.
Fine. So the same potential should be there in both inverting as well as non-inverting input terminal. What is the potential available in non-inverting input terminal? 0. So what is the expected potential at the inverting input terminal?
0.
0.
Okay. So, by the way, I must tell you one point, and this point I'll repeat over several classes also. While analyzing any operational amplifier circuit, whatever may be its complexity, whatever is the complexity of the operational amplifier circuit, the first thing we'll target is to find out whether negative feedback is there or not. In case there is negative feedback, we'll assume the linear operation. Yeah, definitely ultimately virtual short. We'll assume linear operation and infinite open loop gain. Hence, straight away we can assume virtual short. Or what you have just now told me, that as soon as you find negative feedback, you will assume virtual short between the two input terminals. That is the first thing you will be doing. Now, after that, after going for the virtual short consideration, what next you will be doing is you have to apply KCL at all nodes where there is no output terminal involved, output or input terminal involved. I repeat, you have to apply KCL at all nodes where there is no direct involvement of any output or any input. Here in this node, can I apply KCL?
Yes, sir.
No, we cannot.
No, sir.
We cannot, because there is a direct involvement of one input. To apply KCL, what do you need? You need to sum up all the currents entering into that node, all the branch currents entering into the node, and that sum must be 0. Is it not? KCL means what?
Yes. Yes, sir.
KCL at any electrical node is the summation of the branch currents must be equal to 0. Entering into node or exiting the node must be equal to 0. Now, if any input signal is connected here, input signal means what? One input voltage I have connected. I'm not talking about the input current. I'm talking about the voltage input. Now, this voltage input is coming from one voltage source. Now, one ideal voltage source is capable of driving any amount of current you require. Is it not? At a voltage source, you should be capable to draw any amount of current that you require. That's the voltage source. But output voltage is fixed there. Voltage is fixed, but the current may be of any value. Is it not? Or do you have any confusion there?
No, sir.
Huh?
No, sir.
Fine. The thing is, say I have one voltage source. If I connect a 1K resistance here, certain current will be drawn. If the resistance is 10K, the current will be less. If the resistance is 10 ohm, current will be much more. So, from any voltage source, you should be capable to draw any amount of current. That means the current drawn from the voltage source is not known. So, as that input current is not known, how can you apply KCL at this node? Is it not? So, wherever the certain electrical node is connected to one voltage source directly, you cannot apply KCL there. So, I cannot apply KCL here. I cannot apply KCL here. Can you apply KCL here?
No, sir.
Can you apply KCL here?
No, sir. Output.
Why no?
Sir, it's a direct
Output terminal.
The output of the op-amp. Is it not? The output of the op-amp is connected here. Now this op-amp is behaving as a voltage source. So op-amp output current is nobody knows. Nobody knows the exact amount of current that the op-amp output is sourcing or sinking. So I cannot apply KCL here.
Sir, I have a question, sir.
Bolo.
Sir, if in the first step we find out that there is positive feedback, then how should we proceed?
In case there is positive feedback, we'll straight away assume that the output will be either plus or minus V set. There is no question of linear operation. So the analysis freezes there, and I will simply say the output will be either plus or minus V set.
Okay, sir.
So whatever I am discussing with, by keeping in mind that there is negative feedback. So first of all, we will just establish that there is negative feedback in the circuit. That's all. That will be the first target for us. Okay, fine. Now that means this node, and this node, they are ruled out. Now where can you apply KCL?
Zero potential.
Yeah, at the inverting input terminal and at the non-inverting input terminal. In the non-inverting input terminal also there is nothing to do. So only at the inverting input terminal I have to apply the KCL. So if you apply the KCL here, V1 minus 0 by R1 plus V2 minus 0 by R2 plus V3 minus 0 by R3 should be equal to this is the current entering into the node, and that should be equal to the current exiting the node. 0 minus V0 by RF. Okay, so V0 will be is equal to minus of RF by R1 V1 plus, or let me do one thing, minus RF into V1 by R1 okay. Is it clear?
Yes, sir.
Yes, sir.
Now I'll tell you one shorter process. Now there are three input terminals, V1, V2, V3. Let me apply superposition theorem. What do you mean by superposition theorem?
Consider one
as there are
source.
three inputs, let me first find out the effect of V1 at the output, then the effect of V2 at the output, then the effect of V3 at the output. And then finally, all these three effects must be algebraically summed to get the final effect at the output. Now, when you are trying to find out the effect of V1 at the output, what should you do with the V2 and V3? Ground them. If you ground these two, what will be the current flowing through R2?
Zero.
Because this node is 0, this node is also 0. So same potential at the both ends of the R2 resistors. So no current can flow. So same is here also. Through R2, R3 there will be no current. So what this circuit now becomes? With respect to V1 and V0, what this circuit now becomes?
A normal inverting amplifier.
A non-inverting amplifier.
Having gain minus RF by R1.
Yes, sir.
So V0 will be is equal to minus RF by R1 V1. Now output does not only depend on V1, it depends on V2 also. So how do you find out the effect of V2? So with reference to V2 and output, how does the circuit behave?
Inverting amplifier.
Inverting amplifier of the gain?
RF by R2.
Minus RF by R2. So V0 will be minus of Rf by R1 into V1 minus Rf by R2 into V2. So that means this is now the net effect of V1 and V2. Similarly, the effect of V3 will be also be equal to minus of Rf by R3 into V3. Okay, so just by observing the circuit, you should be able to tell me what is the output. Just by observation, you can say it. And definitely using KCL, that is the general process. This is the general process. But once you get expertise, you can straight away, just by observation, you should be able to tell me what will be the output. That saves much of your time. Fine. Now the output is this. What we have here is as if each of the three input signals are being multiplied by the gains, respective gains of Rf by R1, Rf by R2, and Rf by R3. And then they are added and then inverted. So this is called weighted adder. This is your weighted adder. This part is the weighted adder. Each input signal is getting different weights. V1 is getting the weight Rf by R1. V2 is getting the weight Rf by R2. V3 is the input signal is getting the weight Rf by R3. So all these three input signals are being multiplied by their corresponding weights. And these weighted inputs are then added. So here this Rf into this thing, that is nothing but the weighted adder. Then it is inverted. So the resulting configuration is called inverting weighted adder. Clear? Or should I have to repeat any point?
Yes, sir, clear, sir. স্যার একটা জিনিস ওই ভোল্টেজ সোর্স এর ওই পার্টটা একবার বলতে হবে যেখানে ওই কনসিডার করা হয় না ওই এক্সপ্লেনেশনটা মানে V1 V2 V3 যে নোডস গুলো যে কনসিডার করব না
আচ্ছা
ওইটার এক্সপ্লেনেশনটা করে দিতে হবে
সোর্সটা কতখানি কারেন্ট দেবে এখানে this 1 volt source how much current it will send
1 minus VA by 1k so then 1 by 1k 1 milliampere
So is this output current from the voltage source fixed?
No sir, depends on the resistance.
So how can you apply KCL at this node? If you need to apply KCL at this node, you need to know what the exact amount of current this voltage source is sending.
Yes sir.
So that is not known. So why should we apply KCL at that node? Rather, how can we apply KCL at that node?
Yes sir, বুঝেছি
So
yes,
in the electrical node where any voltage source is connected directly, we never go for applying KCL there. Because we know that the node voltage itself is known. We are mainly concerned about applying KCL at some electrical node, because that electrical node potential may not be known, may not be. But here,
Sir, but here the voltage is fixed.
So why
Yes,
to apply KCL there?
Yes, sir.
And apart from that, the branch currents are also not known. Fine.
Yes, sir. Yes, sir.
Now say, during Sanskriti or Apasanskriti, one concert, one DJ party is there. Some or forget about that DJ party, some vocal singer is there. Somebody is beating drum. Somebody is playing guitar, and that singer is singing his or her song. The thing is, maybe that drummer and that guitar, they are very loud. And in front of that drum or in front of that guitar, there must be some microphone to pick up that signal. Is it not?
Yes, sir.
Similarly, just in front of the mouth of that singer, there must be another microphone. Now the microphone is giving you the voltage signal corresponding to the input sound. Let V1 be from that drum, V2 is from that guitar, and V3 is from that singer. Now the singer is having a very low voice, just like me. But the drum and the guitar, they are getting played in very loud volume. So how can the audience hear to the singer's voice?
Sir, will reduce resistance of the singer.
Yeah. So now what you can do is, you apply that to this weighted adder, inverting weighted adder. You apply the 3 signals from the 3 microphones to this weighted adder. Now apply large resistances R1 and R2 for your drum and guitar. So that means their amplification factor is now reduced. But use low resistance for R3. So the gain of V3 will be much more as compared to V2 and V1.
Yes, sir.
So now, in effect, when the net composite signal goes to the sound system, the audience now can hear to the voice of the singer with preference to the your drum and the guitar. So while some concert is going on, you find that somebody sits in front of the singer, and there some with some panel, and he is continuously adjusting something. Basically, he is adjusting these resistances. Oh my goodness, he is adjusting these resistances. If he finds that the singer voice is feeling a bit louder, it tries to increase the resistance R3. So just he is adjusting those resistance values. But definitely the circuit is not so simple circuit. There will be a lot other things will also be there. But the heart of the system is this audio mixer. This is called the audio mixer. So in audio mixture, definitely these inverting weighted adder having quite great use. Is the application clear?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
By the way, what are the input impedances? Tell me. How many input impedances will be there? First of all, tell me.
3.
3. Because there are 3 input terminals, so definitely there will be 3 input impedances involved. As there are 3 input nodes, definitely there will be 3 different types of input impedances. And what will be the respective input impedances there?
R1,
R1, R2, R3.
R1, R2, and R3. For the V1 input terminal, it will be R1. For V2, it will be R2. And for V3, it will be R3. Doesn't matter. It doesn't matter.
So V1, V2, V3 তো equal হয়ে যাচ্ছে।
তো যদি ইকুয়াল হয় কি যায়?
তো নরমাল একটা নন ইনভার্টিং অ্যাম্পলিফায়ার হয়ে যাচ্ছে এটা।
তাহলে আউটপুট কি হবে?
V0 equal to 1 plus RF by RI into any of মানে V generally.
V1
into 1 by 3 into V1 plus V2 plus V3.
Let me see what others say.
Yes.
One thing is sure, in your class, only Parvez goes through the class notes, the previous year's class notes and Arjuma's note before coming to the class. So that's why he always comes out with the answer before the others. But I need others to answer also. I don't want you to come prepared. You just learn here, and that should be sufficient if you listen to me properly. And if you raise your objections in the class itself, doubts in the class itself, you may not need to go through the notes again. Try to give some answer always, even if it is wrong, does not matter.
Thevenin equivalent replace karo.
Now, what is the first step that you have to find out?
Negative feedback আছে তো।
Whether there is negative feedback or not. Is there negative feedback?
Yes, sir.
Yes. So straight away go for virtual short. So if this node voltage is V, this should also be your V. Now, with reference to this V, what is this circuit? With reference to V, what is this circuit, op-amp circuit?
It's a non-inverting amplifier.
Non-inverting amplifier of gain 1 plus RF by RI. So V0 has got to be 1 plus RF by RI into V. Fine? Any objection? Any doubt?
No, sir.
Good. Now you have to find out V in terms of V1, V2, V3. That means you have to apply KCL at this node. Okay. How did you arrive at this expression? Now, by applying KCL at this node. Is it not? Just by applying KCL at this node, we have arrived here. Bolo. Fine. Now, if we apply KCL at this node, what will we having? V3 minus V by R plus V2 minus V by R plus V1 minus V by R should be equal to? Should be equal to?
0.
The R gets cancelled out, and then my V becomes nothing but 3V is equal to V1 plus V2 plus V3. So V is equal to 1/3 of this. Okay.
স্যার কিন্তু Zn equal to infinity এর জন্য ওই নন ইনভার্টিং টার্মিনাল দিয়ে তো কারেন্ট
তার জন্য এই কারেন্টটাকে 0 ধরেছি।
ইয়েস স্যার, কিন্তু
these are the current, some of the currents entering into the node.
Yes sir, খেয়াল আছে, ঠিক আছে।
Okay.
Yes sir, yes sir.
So why did we use
this current going exiting the node? The current going exiting the node is 0.
Yes.
So that, sum of the currents entering the node must be equal to 0. শুদ্ধ কিছু বলছিলেন।
So why did we use similar values of resistance in this case?
Otherwise, you won't get this 1/3. That's all. Otherwise, you won't be getting this expression for V.
So মানে যদি different use করতাম তাহলে we could have gotten
definitely this response you will not be getting. My requirement is to achieve this response. Why? After I explain the resulting functionality which I am getting, you will know. Here, what is the output? How the output is related to the inputs?
Sir, কোন এক্সপ্রেশনটাতে?
এই ফাইনাল আউটপুট এক্সপ্রেশন।
আচ্ছা,
arithmetic mean.
No, not arithmetic mean. It is basically it is adding all the 3 input signals and then amplifying by the factor 1 plus Rf by Ri by 3. 1/3 of 1 plus Rf by Ri. That is the gain of this adder. There is no relative.
Yes sir, voice check it is.
Don't know. There was one call.
Sir, একটু কেটে যাচ্ছে।
Are you still hearing me?
Yes sir, yes sir.
কেটে যাচ্ছে না?
না স্যার, এখন ঠিক আছে।
শুনতে পাচ্ছেন না আপনারা? ঠিক আছে।
Yes sir.
Here the 3 input signals are simply added. And without any phase shift, they are amplified to the output. So this is simply one non-inverting adder. This non-inverting adder functionality you won't be getting if you do not introduce same gain, same resistances here. That functionality you won't be getting. Just simple addition functionality you won't be getting. That will be something else function you will be coming out. You'll be getting.
স্যার যেটা পাবো সেটাকে ওয়েটেডও তো বলতে পারবো না।
এটাকে ওয়েটেড বলতে, হ্যাঁ, তুমি এটাকে বের করে দেখো what is the functionality you are getting, then you should be able to find out.
ওকে স্যার।
And that will not be that simple expression which you got in the previous case.
ইয়েস স্যার সেটাই বলছি, মানে ওয়েটেড মনে হয় না হবে।
Definitely, but the weights will not be something just RF by R1, RF by R2. They won't be simple like that.
Yes.
There, the effects of this resistance and this resistance and all these three resistances will be there. Okay.
Yes.
Fine. Now, say there is the requirement that I need to add 3 input signals, just simple addition. No gains should be there. No extra gain should be there. Just I need V1 plus V2 plus V3. So what would be the RF and RI values?
RF equals to 2 RI.
RF should be equal to RI. Now, in place of only 3 input signals, if there were 4 input signals, what will be the
3 RI.
3:1.
RI equal to 3I.
No, in that case, what will be this expression?
V1 plus V2 plus
1 by
V3
4.
1 by 4 into 1 plus RF by RI, V1 plus V2 plus V3 plus V4.
Yes.
So there, if you want to go for simple summation of VIs, just that summation, in that case, your RF should be equal to 3 times VI, RI, or RF should be always equal to N minus 1 times RI, where N is the number of input terminals, where N should be your number of inputs. If the value of N is 5, RF should be 4 times RI. If the RF value of N is 2, in that case, RF should be equal to RI. Okay? Is this point clear?
Yes, sir.
Yes.
Fine.
Yes, sir.
Oh, by the way, the previous circuit was called non-inverting adder of gain 1 by N, 1 plus RF by RI. Where N is the number of input terminals. Okay? I have mentioned that. I am now telling you.
স্যার অফ গেইন ওই জিনিসটা বলতে হবে যদি রেস্ট্রিক্ট করতে হয়।
Definitely. If you are saying that it is just non-inverting adder, that means it is giving you only beyond summation of VI.
আচ্ছা, সিম্পল অ্যাডার যেটা সেটা রেফার করছে। ওকে।
যেমন একটা যদি not, if I say that I have one inverting amplifier, I should specifically say inverting amplifier of gain such and such. If I say I have one non-inverting amplifier, once again I should say the non-inverting amplifier of gain such and such. Okay, so these things we should mention, but sometimes we omit also. But anyway, that doesn't matter.
স্যার কেসিএল বা সুপারপজিশন থিওরেম যে কোনো একটাতে ইউজ করা যেতে পারে নেগেটিভ ফিডব্যাক আইডেন্টিফাই করার পরে।
Definitely. Once you gain experience, you can always apply superposition theorem. Otherwise, definitely it is safer to go for KCL, because that will there is less chance of making mistake, but that will definitely kill more time. Is there negative feedback?
Yes, sir.
Yes, sir.
So straight away we'll be going for virtual short. Do you know this node voltage?
Yes, sir.
No, we don't know.
No,
Is it directly given?
No, sir, not directly.
So let me assume it V. So this node voltage will also be your V. Now, by applying KCL at this node, non-inverting input terminal, I can find out V. So that V is nothing but is also that potential divider thing. So N by 1 plus N.
N by N plus 1.
Okay. So
Yes, sir.
now here you have to apply KCL at the inverting input terminal. So V1 minus V
1
by
plus N.
R1 will be equal to V minus V0 by NR1. So R1 gets cancelled. So your V0 is equal to V plus NV minus NV1. বোধহয় ঠিক লিখেছি। NV1, NVV. Fine. So that's equal to 1 plus NV minus NV1. Now substitute the value of V. Okay. So substitute করলে কি পেলাম? This is NV2. Okay.
Sir.
Yes, sir.
What is the operation you have got?
So gain N.
Basically one subtractor, one difference amplifier. One subtractor or one difference amplifier with the gain N.
Yes, sir.
Or subtractor or one difference amplifier with the gain N. So this way you can realize one inverting amplifier, one non-inverting amplifier, one inverting weighted adder, one non-inverting adder, and one subtractor or one difference amplifier. These are the 5 basic circuit topologies. এবার এইগুলোই ইউজ করে করে we can expand our experience in operation amplifier circuits. But here in this difference amplifier there is a problem. Now the two arm ratios, this R2 NR2 and R1 NR1, these two arms, the ratio of these two arms must be always same. This NR1 by R1 and NR2 by R2, this ratio must be always same. Otherwise, you won't get the subtraction operation. That means to get subtraction operation or pure subtractor operation, you need to have this arm ratio and this arm ratio same. Both must be n. Then only you'll be getting n times V2 minus V1. Otherwise, you'll be getting some other V0 value, which may not be proportional to V2 minus V1. So if that is not proportional to V2 minus V1, definitely you are not getting one pure subtractor. Okay, so we need to ensure the two arm ratios remain same always. Now say I have designed one subtractor of gain 2 by introducing R1 is equal to 1K, NR1 is equal to 2K, and R2 is equal to also 1K, and NR2 is also equal to 2K. Now after 1 day or 2 days, I find that my requirement should not be exactly 2 gain, it should be 2.5 gain. Now I need to vary this arm ratio and this arm ratio exactly in the same manner. Now varying two arm ratios of the resistances in the same manner is very, very difficult, if not totally impossible. I can fix one set of equal arm ratios by design, by fabrication. But if I go for the variation, it's very difficult to achieve exact same variation so that the arm ratio remains the same. Remains the same means the arm ratio of the feedback path and the feedback path to the inverting input terminal and the input path to the non-inverting terminal to remain the same. That is quite, if not impossible, it is quite difficult task, very difficult task. So variation of gain in the case of this type of subtractor or difference amplifier is a real headache. But we do use these subtractors in our instrumentation field quite often. Where? কোথায় এর application? Say, I have a plant. The plant, the actual process may be quite hazardous process. So from there, I have picked up certain sensor output, some transistor, some sensor output. Now that electrical output I have to process in my control room. Now definitely my control room will be situated quite far away from the actual hazardous process. That should be in one safe location. So I have to transfer that signal to the control room. Now the signal that is being transferred from the process to the control room is not very large signal. That will be quite small signal of the order of millivolts, several millivolts, maybe 10 millivolt, maybe 20 millivolt, maybe 100 millivolt. It will barely move above 1 volt. Now say if this wire length is nearly 500 meter or so, so in the process of moving that signal, transferring that signal from the process to the control room, that wire will definitely pick up electrical noise. Now that electrical noise may be also of the order of millivolts. So once you receive in the control room the noisy input signal, how will you distinguish the actual signal from the noise? Any idea? How can you eliminate the noise? How can you try to eliminate the noise?
So zero উপরে নিচে levels হয়, and if the signal goes above that level it is not noise, and if it is below that level it is noise.
Oh, but the thing is that the process output is an analog signal.
This subtractor can work.
Yeah. The process output is analog signal. So there is no question of introducing any threshold. My process output may be itself of the order of 50 millivolt. So how can you set any threshold? The threshold is, you can use the threshold when the output is binary. Isn't it? When the output is binary, output of the process is binary, there also, there only you can use a certain threshold. Otherwise, for analog signal, you definitely cannot use any threshold. Now, well, communicating the signal from the process to the common room, only that the live wire is not sufficient. I need to communicate the reference line also. This reference line I need to communicate also, because this is 50 millivolt with reference to this reference signal, isn't it? If I say certain output is 1 volt or 2 volt, with reference to what it is 1 volt, with reference to what it is 2 volt, that I must mention. This ground level or reference level, I must also communicate from the process to the common room. Now what we do is, we twist these two wires together. They are twisted. Now whatever electrical noise is picked up between this end and this end, that noise will corrupt both this wire signal and this wire signal equally, isn't it?
Yes, sir.
Yes.
So that means reference and the original signal both will be corrupted equally. Now what I will be doing is, I will be using one subtractor. Here I will connect this fellow, and here I will connect this fellow. So at the output, what you will be getting? This is your V, I, and this is your reference. Is it not? So at the output, you will be getting VI minus reference. That is the VI signal itself.
Yes.
Yes.
And the noise which was here, that same noise is also here.
Yes, sir. So that will get eliminated.
So that noise gets cancelled out here. So I will be getting only VI. So even if my noise signal is having more amplitude, more magnitude than the VI, does not matter. Noise will get effectively cancelled out. So low input signal will also be detected here. Okay. So the subtractors do have quite a large number of applications, they are quite useful in instrumentation field. So definitely before using the signal in the control room, they must be processed through one difference amplifier. But in this type of difference amplifier, what is the problem?
The gain cannot be changed easily.
The gain cannot be easily changed. আচ্ছা এর পরে কি ক্লাস আছে আরবি স্যার
হ্যাঁ স্যার ক্লাস তো আরবি স্যারে আছে বাট হবে কিনা জানি না মনে হয় কালকে অফলাইন
আমি 5 মিনিট দিয়ে নিচ্ছি জাস্ট 5 মিনিট দিয়ে নিচ্ছি আচ্ছা now let me go back here. In this difference amplifier, what are the input impedances? How many input impedances will be there?
2.
The 2.
One is seen by this, the other is seen by this. What will be impedances that input impedance that is seen by this terminal?
So repeat.
What will be the input impedance that will be seen by this terminal, this V2 terminal?
Sir, N by
অনিন্দিতা কি বললে শুনতে পেলাম না মা
N by N plus 1 R2.
No.
Sir, 1 plus N whole R2.
Yeah. There is 1 plus N into R2. What will be the II? II will be V2 by R2 plus NR2.
NR2.
So your Z in for this input terminal will be R2 plus NR2 or 1 plus N into R2. Okay. What about for this one?
R1.
There's nothing but R1 only. Because when you are trying to find out this input impedance, this is assumed to be grounded. So this node voltage will be 0. This node voltage will be 0. So this will be 0. So the II here will be nothing but V1 by R1. So Zin for this terminal will be nothing but your R1. Are these input impedances infinite?
No, sir.
So these input impedances are definitely not infinite. So let me go back to that inverting adder. Yeah. Here tell me what are the input impedances?
So R1, R2, R3 respectively.
No.
3R by 2.
Yeah. If you go for this one, what you are effectively seeing, this is grounded, this is also grounded, isn't it?
Yes, sir.
So that is as if your V1, R1,
parallel দুটো R.
Sorry, R1 না R.
স্যার বাট কারেন্টটা তো 0 ছিল এখানে।
কোনটা?
স্যার কারেন্ট যেটা যাচ্ছে।
কারেন্ট তো 0 নয় এখানে। এটা কি 0 ছিল কারেন্ট?
কারেন্ট V থেকে 0 যাচ্ছে।
এটা 0. This current is 0.
হ্যাঁ, বাকি দুটোকে যদি আমি গ্রাউন্ড ধরি তখন তো মানে ওইটা 0, ওই বাকি দুটো ব্রাঞ্চে 0 তবে
এটা কি 0? এটা কি 0? এই নোড ভোল্টেজ কি 0?
না
তাহলে কি করে ধরতে পারো যে কারেন্টটা 0? কারেন্ট তো 0 তখনই হবে একটা রেজিস্ট্যান্সের বোথ এন্ডে যদি সেম পোটেনশিয়াল থাকে।
ইয়েস স্যার।
এক মিনিট আসছি আমি। এখন উঠতে পারছি না। কোথায় ছিলাম গো? This is R parallel R, that is R by 2. So net impedance that you are seeing here R plus R by 2, that is 3R by 2. That will be the input impedance as seen from the V1 input terminal. That will be the same impedance seen from V2, same impedance seen from V3. এই জায়গাটা ছিলাম না অন্য কোথাও ছিলাম?
Yes, sir.
Fine. So in any case, what we find here is also that the input impedance is not infinite. So we have seen input impedance infinite only in the case of non-inverting amplifier. In nowhere else we are getting infinite input impedance. So in the subtractor also we are having subtractor. Yeah. Here in the subtractor also we are finding that the input impedances are not infinite. But as the subtractor is having wide application in instrumentation field, so definitely we must try to achieve some subtractor where the input impedance is infinite and at the same time the gain can be varied very easily. So that is none of those two objectives are getting satisfied by this subtractor. Here the gain cannot be varied very easily, nor the input impedances are very large. So in the next class we will try to find out what can we do to increase the input impedance and to make sure that the gain can be adjusted very easily. But here, can you tell me some modification in the subtractor by which we can introduce infinite input impedance?
So buffer.
Yeah, you do one buffer here, another buffer here. So that way, definitely you can avoid the problem of non-infinite input impedance by using the buffers. But the gain cannot be adjusted very easily. That will be very difficult one. Okay, so next class আমরা ওইটা ডিসকাস করব। আচ্ছা, এইবার তোমার শুরুতে তোমরা একটা বলছিলে ক্লাসের কন্ডাকশনের মেথডটা কয়েকজন আমাকে
একটা ডাউট আছে স্যার।
হ্যাঁ, বলে
স্যার ওয়েটেড সাবট্রাকশন বলে কিছু হয়?
ওয়েটেড সাবট্রাকশন বলতেই পারো, বাট অ্যাজ সাচ তার কোনো অ্যাপ্লিকেশন আমরা এখনো পাইনি। ডেফিনেটলি বলতেই পারো, যেমন ওয়েটেড অ্যাডারের একটা গল্প বলেছি আমরা, সেরকম বলতেই পারো। বাট যখন অ্যাডার বলি বা যখন সাবট্রাক্টর বলি, বেসিক্যালি দে মিন টু গো ফর সামেশন অফ ভিআইস, অর সাবট্রাকশন যখনই বলি উই গো ফর V2 minus V1.
Pure addition, pure subtraction always.
Yeah, yes.
Okay, sir.
হ্যাঁ, এবার ওইটা তোমাদের কি বক্তব্য আছে আমাকে বল।
হ্যাঁ স্যার, আমি বলছিলাম কি অনেকজন আমাদের মধ্যে থেকে চাইছিল যে অনলাইন হোক আপনার ক্লাসগুলোটা, কেন কি রেকর্ডিং ওর মধ্যে ভালো হয় স্যার। অনেকরা আছে কি রিয়েল টাইমে মানে কি হতেই পারে কি একটু কিছুটা বুঝছে কিছুটা বুঝতে পারছে না, তাহলে ওদের ইউটিউব চ্যানেলে গিয়ে ওরা আপনার লেকচারগুলোকে ভালো করে ফলো করে নেয় স্যার, আর রেকর্ডিংটা ভালো হয় স্যার, ভালো কোয়ালিটিতে হয়ে যায়।
যেটা প্রবলেমটা যেটা বললাম, আমার তো প্রভিসি একটা নোটিশ দিয়ে দিয়েছেন, অ্যান্ড অ্যাট দ্য সেম টাইম তোমাদের ইউনিয়ন থেকেও ওই অবজেকশন তুলেছে, মানে বলটা টিচারদের কোর্টে ফেলে দিয়েছে যে টিচাররা নাকি ক্লাস নিতে রাজি হচ্ছেন না, তাই ক্লাস হচ্ছে না। ওরা ক্লাসে গিয়ে দেখেছে যে
আমাদের ডিপার্টমেন্ট থেকে একদমই জিজ্ঞেসই করা যায়নি।
আমি সেটা জানি, সেটা জানি, সবসময় তাই হয়। এবং নর্মালি আমরাও যেমন টিচাররা অনেক সময় আমাদের টিচার্স অ্যাসোসিয়েশনের ডাইরেক্টিভের বাইরে গিয়েও আমরা ক্লাস করি বা অনেক কিছু করি, সেমনি তো আমাদের স্টুডেন্টরাও সেটা করে। এবার তোমরা যদি সেটা, ইফ ইউ ওয়ান্ট দ্যাট, দেন ইউ হ্যাভ টু গিভ সামথিং ইন রাইটিং সো দ্যাট উই ক্যান ডিফেন্ড আওয়ারসেলফ।
ওকে,
এবার সেটা তোমরা আদৌ রাজি আছো কিনা সেটা তোমরা ভেবে দেখো।
ওকে স্যার।
স্যার আপনি লাইক ফাইনালি বলে দিন স্যার, কারণ কি টিকিট কাটার ব্যাপার আছে তো স্যার, আপনার ক্লাসটা না হলে লাইক আমি যাব না স্যার ওটার জন্য।
না, সে তো আমি বলতে পারি না, আমাকে তো সোফার প্রভিসিস নোটিস ইজ ইনস্ট্রাকশন ইজ দেয়ার, আই হ্যাভ টু টেক দ্য অফলাইন ক্লাস।
তো যদি ওটাই হয় স্যার, কবে থেকে স্যার অফলাইনটা নেবেন আপনি?
আমাকে সত্যি বলতে কি প্রভিসির যে নোটিস ছিল আজ থেকে নিতে হবে।
তো আজ তো হলো না স্যার, পরের দিন থেকে মানে 14th থেকে আপনি অফলাইন নেবেন?
না, এবার সেটা ডিপেন্ড করছে যদি এবার ওদের প্রভিসির কাছে ইমপ্রেশন কাছে স্টুডেন্টরা সবাই চাইছে, টিচাররা চাইছে না বলে অনলাইন কন্টিনিউড হচ্ছে।
স্যার আমি বলছিলাম কি রাইটিংটা কোথায় দেবো স্যার, মানে আপনার
না হেডের কাছে।
ওকে স্যার, ওকে স্যার।
কেন কি উই আর বিং কন্ট্রোল বাই দ্য হেড ইজ বিং ইনস্ট্রাক্টেড বাই দ্য প্রফেসর প্রভিসি।
কিন্তু আরেকটা জিনিস হবে যে লাইক এমন হয়ে যাবে যে অর্ধেকজন চাইবে যে অনলাইন হোক, অর্ধেকজন চাইবে অফলাইন হোক, মানে ব্রাঞ্চের মধ্যেই কনফ্লিক্ট হবে।
একটা প্রবলেম হচ্ছে স্যার, ধরুন আপনি বুধবার সকালে ক্লাস নেন, আবার আপনার ক্লাসটা হওয়ার পর বুধবার বিকালে ক্লাস ল্যাব যেটা সেই স্যার যদি বলেন অফলাইন হবে, তাহলে আমরা ক্লাস করে যাবো কিভাবে? মানে যাতায়াতেরও একটা প্রবলেম হবে। মানে
এবার তো যেটা হচ্ছে, যদি অফলাইন হয় এভরিথিং শুড বি ইন অফলাইন মোড।
স্যার ওটাই তো স্যার, হাইব্রিড মোডটা খুব বাজে স্যার, হাইব্রিডে যাওয়া আসা তো ঝামেলা না স্যার, ইদার অফলাইন পুরা या फिर অনলাইন পুরা, হাইব্রিড মোডে তো স্যার বেকার।
সেটা আমার টিচারদেরও মুশকিল, because I am also facing the same problem. In Monday, in the first half, if I have to take the offline theory class for you, and in the second half I have online lab. এবং আমার ডিপার্টমেন্ট থেকে অনলাইনে আমার কানেক্টিভিটি খুব পুয়ার।
স্যার তাহলে মানডে অফলাইন ক্লাস হচ্ছে, এটা কনফার্ম?
সেটা এখন আপ টু ইউ ওনলি।
Sir, you can take online, sir.
But then,
no, I can take everything.
Sir, যখন আপনি completely
you have to come out from your end.
স্যার আমাদের ব্যাচে তো কনফ্লিক্ট হবে স্যার, লাইক 50% চাইবে
স্যার
অফলাইন
কেন
আর
যে
50% অনলাইন হোক।
অনেকজন অফলাইনে চাইবে, অনেকজন অনলাইনে
In
চাইবে।
that case, that will be contacted in the
হ্যাঁ
offline
স্যার,
mode
তো
only.
মানে যদি সেটা হয় তাহলে তো স্যার মানে বেসিক্যালি আমরা ধরে চলতে পারি কি অফলাইন হচ্ছে না।
Definitely.
ওকে স্যার।
That is the directive of the union and vice chancellor.
ইয়েস স্যার, ওকে স্যার।
So if you want something else, you have to come out in writing and give it to the HOD.
স্যার রাইটিং এ মানে কি সব স্টুডেন্টদের সিগনেচার লাগবে এন্ড স্টাফ, ওই টাইপের কিছু?
No, we normally assume the class representative is the representative of all the students.
তো মানে ক্লাস রিপ্রেজেন্টেটিভ শুড টেক আ ভোট অর সামথিং না?
Definitely, that's why he is the CR.
ওকে স্যার।
CR should write to the HOD on behalf of the students. That's all.
হ্যাঁ স্যার।
Okay. So সেটা করে আমাকে জানিয়ে দিও, accordingly we'll decide.
ওকে স্যার।
কেন so far আমাদের কাছে একটা কনসেনসাস হয়েছিল যে উইল বি স্টার্টিং ফ্রম 21st.
হ্যাঁ স্যার, আপনি পিছলা ক্লাসের ওটাই বলেছিলেন।
হ্যাঁ। Okay. But for that also I need your written request.
স্যার যদি কোনো রিটেন রিকোয়েস্টই না যায় তার মানে 14th থেকে ক্লাস হচ্ছে?
তার মানে 14 থেকে ক্লাস নিতে বাধ্য আমি।
ওকে স্যার।
আনলেস আমার অন্য কোনো পার্সোনাল প্রবলেমের জন্য আমি ছুটি নিলাম। Okay, so you decide and Joydeep, you just come get back to me.
Okay, sir.
Okay. So hope up to this point no further confusion regarding theoretical classes, the topics that we have discussed.
No sir.
No,
No,
sir,
sir.
no problem.
No, sir. No, sir.
Okay, then I'll no more attendance.